Hello YouTube, this is Jeff the C. Mars again, and welcome back to Universe Sandbox 2. Now in this video, we're going to try a couple interesting things. The first thing we're going to do is we're going to take the main bodies, which is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, and put them all in reverse order. So basically we get rid of the bodies and we just put them where they are from the sun. Now of course I gotta look those distances up. Now I'll do that very quickly. Okay, back and I found them. So we're going to, of course, we're going to slow this down first of all, and then we're going to pause the simulation. And basically we're going to delete every planet that there is, because we're going to make this reversed. But only the main bodies. We can't reverse everything. So there we go. So these two are not really like main bodies. So of course the first thing we're going to add is Pluto, because that's the last body in our solar system. And Mercury is 5.79 million kilometers. I gotta, that's I think that's a million, isn't it? So Mercury is 5.79. I need to look at the zeros. So that's okay. So that is million kilometers, I think. Is that correct? Let me count those zeros. So 57.9. So that's 100 million. So it's before that. So it's 57.9 million kilometers. We just says it's hang on. It's hard to see. Oh wait, that's not correct. That's supposed to be a million. My bad, this is 10 million, my bad. It's hard for me to see, I'm sorry, but the numbers are pretty small. So, yeah, this has to be million. This is 839. Yeah, that's, okay. There, okay, we're getting it. So, 57.9. So, right about there is where Mercury is located. So now we're going to put Neptune at Venus' distance, which is approximately 182 million kilometers. So of course that's, if we're going to get to 90. Yeah, okay, so continue going. Now that should be 100 million kilometers. So 108.2. So right around there should be Venus's distance. If it's correct. Now Uranus is going to take Earth's spot. Earth is 1 astronomical unit, so we can just add that at 1 AU. So there's Earth's distance. Now Saturn's going to take Mars's place. So Mars is 1.524 astronomical units. So 1.524, we could just do 1.52 is the best we can do. Right around there is Mars. Now, ironically, Jupiter, even though I got rid of it, ironically, Jupiter is the same position because it's the 5th. So ironically, I guess I did not need to get rid of it. Anyways, so this is from the Sun. Jupiter, we just put it back, is 5.23 astronomical units, so we could just put 5.23 is the best we can do. 5.2, sorry. There we go. Wait, did it go? Did it, no? I don't think it placed it. Okay, let's do this again. Okay. I don't think it worked. So, there we go. Okay. So now we're going to Mars. Mars is taking Saturn's place, so Saturn is 9.539 astronomical units away from the Sun. So for that, we can do 9.53 best. Sorry, that's too close. 9.53. 9.53. Right there. That's approximately Saturn's distance. Now, Earth, of course, is not going to do well with this, but Earth is taking Uranus's position, which is 19.8 astronomical units away from the Sun. So, basically 19.1 to keep the story short. There we go. Now, Venus. Venus is taking Neptune's position. Neptune is 30.06, so basically 30 astronomical units away from the Sun. And then finally, we're going to put Mercury, which is taking Pluto's place. Pluto is 39.53 astronomical units, so just 39.5 to keep the long story short. 39.5. Right there. So the solar system is now reversed. We're going to speed this up to what it was at the start. I think it was that. So let's do this. So Pluto, of course, Pluto's actually losing its atmosphere because it's so close to the Sun now. It's not used to this. So Pluto is getting scorched. That's what it looks like. Its temperature is not increasing too much, surprisingly. Let's check on Neptune. Oh, I think Neptune and Uranus. Hang on, let me do something. So let's disable collision so we're gonna make so planets cannot collide. So Neptune is doing fine here. Uranus is doing fine. Actually, Uranus is still below. Wow. Alright then. So Pluto is probably still being scorched. Yeah, it is. So Saturn is doing fine. Actually, pretty much every planet will do fine except for Earth. Mars is of course colder than it is. Earth has frozen basically at this point. Yep. And it's not completely frozen just yet. So has water on it, but not for long. So Venus is gonna dramatically cool down, definitely, because it's farther away. Yeah. Yeah, see, Venus is in the negatives too. Of course, it's not really going to change much. And we're at Mercury. Yeah. That's going to decrease soon. So let's just accelerate this to that much per second. And we're going to see, Jupiter is the same place as it was originally, so we no need to get rid of it. We can feel the habitable zone. So yeah, that's where Earth is pretty much, in the habitable zone around the Sun. So basically, in long story short, if we reverse the solar system, Pluto will be scorched. Even though, so Pluto will, so to keep the long story short, Pluto would be scorched, and it still is being scorched. So Pluto will be scorched. That's what it looks like it is. And then Uranus, Neptune, Uranus, Saturn, Jupiter, pretty much all the planets except Earth would do fine. That's to keep the long story short. That's the first one. Now I'm actually gonna save this. And it's the inverse solar system. There. Okay, so the next one we're gonna do might sound crazy, but this next one. Oh, hang on, let me open. Actually, you know what? I could make a new one. So let's add the Sun quickly. Sun. Because we're basically going to, this experiment is going to be, what would it look like if the other planets were Earth's moon? This might not technically be possible because, like Jupiter and the gas giants might be too big. But we're just going to try it anyways. We're at the whole system. With this whole thing 1 astronomical unit away from the Sun, because that's where Earth is in real life, in the Sun. 1 astronomical unit, or 1 AU. So right there, that's where Earth is approximately from the Sun. Let's just let it adjust. This is approximately 1 astronomical unit from the Sun. If you have a habitable zone, it should be fine. That is approximately where Earth is in real life from the Sun. Now, another thing we got to do is disable collisions, so there's no collisions in this simulation. So it should allow Earth to just stay in the orbit. So it's going, I think it's like getting, let's see where the moon is right now. So we want the moon to be on the day side of Earth so we can actually see it in the sky. Then we'll replace it with the other planets of the solar system. Of course, I looked up the moon's distance from Earth. It is 384,400 kilometers from Earth. So we're gonna, let me actually view orbits so I know when to pause it exactly when it's on the daylight side of Earth. because that's where we're going to put the other bodies, because they might not work. And we're not even going to run this, and we're just going to like pause it. And there. So now the moon should be visible from the surface of Earth if we go to the surface of it. This is going to be the ocean, but so what? It's not really directly on the surface. Let's look up. Where's the moon? Where are you? Moon. Moon. Oh. I can't even see it. Ah, right, because it's right in front of the Earth, so it's blocking the sun. Actually, is that a solar eclipse going on right now? I think it is. Anyways, we can't see the moon like that. That's not gonna work. So I want the moon to be visible from the surface of Earth, though. So let's see. Let's pause it here. And what side is facing Earth? Still kind of looks like a shadow is facing. Actually, it's not even like there. Okay, keep it there. Now it looks like a half of it would be seen from Earth. Let's try to go in on here. Well, that's good enough. Anyways, where is it? Oh, it's there. Let's disable orbits. Let's disable labels. And let's get rid of this showing. Oh crap! I lost it already. No, I didn't. It's okay. So this first one, can I take a screenshot? What happened? Oh. Well, is it possible for me to take a screenshot while recording? Well, I'm going to enable it. Let's see what happens if I do Control B. Okay, the screenshot was taken. Good. Okay. What? No. I don't want to change the recording mode. I just want to switch to that. Okay. Alright, so we did that. So this simulation will never be played. Like, continue to play. So the moon. I just want to add a moon, like, right next to it to see what the game says the moon's distance is. Well, that's average, so it's close enough. Anyway, so we're gonna keep the moon here because we're gonna add. So we're gonna start with Mercury. Of course, Mercury is, of course, bigger than the moon. But once we're gonna remove the moon after we add Mercury because we want it to be the same place in the sky. However, so view orbits. So we gotta keep this on. We gotta keep it in this spot, around that spot. So the way I'm going to achieve this is, well, sort of add it inside the moon. Actually, this is yeah, let's put it like inside the moon, but like yeah, let's just put it in the moon. The moon, is the moon still in it? Yeah, the moon is. The moon is inside Mercury right now. I think it is at least. Yeah, it is. The moon. The moon. Hey, why can't I slap the moon? Oh, I can't slap the Mercury. Oh, whatever. The simulation will not be played anyway, so it's fine. Now, we're not going to do Pluto on this one because Pluto won't fit the other planets. Well, it won't be fair for it. Let's head back to where we were before approximately, off the coast of Florida, as you're kind of on it. And let's look up to find Mercury in the sky. So that's Mercury as our moon, pretty much. Okay, so the next one we're going to do is Venus. Whoops, didn't mean to do that. Sorry. Let's head here. Okay, so the moon's inside Mercury, but that's fine. If I were to do Pluto, actually, is Pluto a little smaller than the moon? I'll have to figure that out later. Anyways, the next one is Venus, because the simulation will never be played, because it's not going to end up well. But, well, I disabled glitches, but still. Actually, is it on top? It should be. Why is it on top? It should be on the grid. I don't know. Venus should be on the grid, not above it. Anyway, so it's around the same distance from the moon, so we're gonna have it there. Actually, I think it's above Mercury, so yep, it is. So we have to delete Mercury and delete the moon, but Venus is our moon now. Again, the simulation will never be played because it's not gonna go well. So let's land on Earth again around the same spot, and let's see where it is. In this case, see Venus as our moon. There is Venus as our moon. This actually looks pretty cool. I'm actually glad we're doing this. Well, next one, of course, is Mars. Now, Mars is smaller. Actually, I might have to. Where's Mars gonna be? Is it gonna be in it? Oh yeah, it is. Yeah, it is. So we're going to have to put Mars. Like right on the edge of Venus on one side. It might be a little more farther than the moon, but it's perfectly fine. We're going to get rid of Venus. So now Mars is our moon. So now let's go back onto Earth and see. Now, of course, I might show you screenshots afterwards if I edit this, but VideoPad sometimes lags when it edits, so yeah, let's look up. And there's Mars as our moon. Hey, Mars. Now, the next one, I'm not sure if it's gonna work, which is Jupiter. I don't know how Jupiter's gonna fit there. Well, we'll try to make it work. Oh, Jupiter's actually, oh, okay then. So what's this, 384? That's around the distance of the moon. So now this is Jupiter as our moon. It actually does fit in the area. Look at Jupiter as our moon. Where are you? Oh my god. That must be terrifying. But that's Jupiter as our moon. Okay. So with Saturn, I want to have rings on Saturn. That's what I want to have. I want Saturn to have its rings, because normally it doesn't. Let's put the same distance from the moon. About there, that's good enough. Now again, I want to add rings to Saturn, if I can. Add rings, yeah, add rings to Saturn, because that'll make it look better. So there's Saturn with its rings. Let's go on to Earth now. This is gonna be laggy a bit until I get good controls to get rid of the rings. And there's the sun. There's Saturn as our moon, of course, with its rings, which they look lovely. Anyways, now let's see. Get rid of the rings by doing Control Z. Yep. Now we're gonna get rid of Saturn. Actually, we could do Pluto. We just have to. Yeah, we'll do Pluto at the end. So I'm gonna do. Where'd it go? Okay. We're gonna do Uranus now. Again, the same distance, approximately the same distance from the moon as the moon. Right there, approximately. Step back onto the surface, and we'll see Uranus as our moon. There's Uranus as our moon. Of course, Jupiter would be like. Actually, I think Saturn would be the biggest view because of its rings. So Saturn, I think, technically would be the biggest view of the moon because it would have its rings, like to make it look bigger. Well, I mean, if you want to do the size of the image, Saturn would be the biggest image to take, probably because of its rings. Anyways, let's go back on the surface. I'm trying to do it around the same position, so it's fair. So there's Neptune as our moon. These planets look cool as our moon. They look cool to me. Right, so the last one we're going to do is, of course, Pluto, which is the last one. We cannot do the sun. That won't even work. So where are you? Here's Pluto. It's smaller than Mars. It might be smaller than the moon, actually. Let's put it at the same distance from Earth. I need Earth distance, not the distance at Mars. So, sorry, again, about 380. This is not Mars, really? Okay, fine. Be like that, Mars. Okay. Step back. Add it again. What? Oh, okay. 384. Right about there. So this is the last one we're going to do. This is Pluto as our moon. And then going to end the video. I have to receive this. Is that it? Oh, there it is. There's Pluto as our moon. Of course, it's smaller than the moon. Well, actually, it might be. Let me actually just test this right now. Is Pluto, in fact, smaller than the moon? Let me get our moon and put it. Wow, look at this. Look at this. Pluto is smaller than our moon. Look at that. Wow. Poor Pluto. I feel bad. Alright, so that was, of course, the two experiments we did in this video. If you guys did enjoy Universe Sandbox 2, please leave a like. And if you want to see more videos, consider subscribing, because I do Roblox videos, and if you like space, I will have those videos uploaded at times too. This has been Jackson Isaac. I'll see you all on the flip side.